Alright guys, so to continue our theme of parametric design, today we're going to be going through the entire molding process of how you can take a simple 3D printed part, mold it, and then cast it in whatever material you'd like. So in the world of model making and molding, you always have a consistent flow and all of the materials that you're using can be completely interchanged. Today we're going to be making a 3D printed file that you can pick, or you can use whatever we'll be working with today. We will be putting it through basically a virtual silicone molding process. And the goal of today is going to be to find out exactly how much silicone do you need to use. Silicone is a very expensive material to buy, and so if you can reduce that and find out exactly how much you'll be using, that'll be much better. So throughout the molding process, you'll always be starting off with your initial material. It's usually called a buck, and it can be made from clay, wood, 3D printed material, anything you'd like. But very often through the molding process, you either want to have a really hard material or a completely different material than what you started off with, or you'd like to have some of the reproducibility if you're going to go into a manufacturing process for a business. But regardless, you always have to get a 3D negative, usually made out of silicone or polyurethane, that you can then fill with another material known as a casting. Now, this casting material can be anything you'd like. If you want a really hard project, you can be making it out of polyurethane. If you'd like to be made out of concrete, if you want to be filling it with chocolate, you can really do whatever you'd like. But the whole process starts from buck to the molding to the casting. So today we're going to be going through a process of downloading an STL from Thingiverse, putting it through the rules so that we can make a little silicone box and then figure out exactly how much volume of silicone we'll actually be needing. Because we're going to be making this, we need to be pouring this silicone into something, we're also going to be making a molding box. Usually made out of a very cheap flat material, something like foam core that you can then crack away, and basically it'll be filling up our volume of silicone that we can pour into so you don't get any spills or any leaks. So we can start off by going to Thingiverse and finding any model you'd like. I found this low poly skull that I really enjoy. I've printed it a bunch of times. It always looked really cool. And whoever made this put in some really cool, interesting features into this, where it's still got that kind of cool low poly design that everyone likes, but it's instantly recognizable what it is. So we can go down into our thing files down here and download it. And you'll notice this is going to be downloaded as a .stl file. An STL is just a really common 3D file that you can use to translate lots of information really efficiently. So we can go ahead and download this right here, and then we can go ahead and pull it up in Fusion360. So going back to Fusion, we can now start on our project. So the first thing we'll want to do is change over our units from millimeters to inches. So like I said, that bounding box that we'll be using, or the molding box, is usually made from foam core that's about 1/4 inch or so, and because you always want to be working with CAD with some kind of physical tangibility, working with material that kind of already exists in real life is a really good way to kind of scale exactly how large or how small things feel, just so you can kind of build a little bit more tangibility. Anytime I'm doing any CAD modeling for a client, I always have a pair of calipers or a tape measure, something that I can physically reference against. So changing it to inches and then working with material that we know that we have, it'll make things a little bit easier to work with. So go ahead and hit OK, and then we'll be starting off by making a new component. You can go into the Assemble menu and click New Component. We'll be going over what components are, what's the difference between external and internal when we go into the assemblies portion. But for now, we can just make a new component that is internal, and we want to rename this so it is Skull. Anytime you're working on a project like this, name things immediately. It's a really good way to keep organized and make sure you don't forget accidentally what parts are. So we can go ahead and click OK, and as soon as we do that, we can jump to our browser, and you can see that we've now got a new component right here called Skull. You'll notice that our icon right here is a little white cube. And now that we have this in a subfolder of our main file that we haven't saved yet, the icon up here is a bunch of white cubes. So this is our assembly file. In a very simple way, a bunch of components that are connected together make an assembly file. And within those components, we can have a bunch of bodies. And the bodies are just tools that basically make up what our component is. The bodies are not the final process, but they are the tools that make up our components, which are the real life things. So now that we've downloaded our part, we can go ahead and insert that. So now that we have our component already highlighted or activated with this little black dot right here, we're now going to go into the Insert menu right at the very top and go ahead and click Insert Mesh. And now we can click the file that we just downloaded. So this insert mesh right here, the very important thing right here is the unit type. Now, Thingiverse is meant for 3D printing mainly, so everything is based in millimeters. So go ahead and change this unit type from inches to millimeters, or else things are going to be 25.4 times larger than they really should be. As far as the position, the location, we really don't care too much about that, so we can just click OK. Now we've got our mesh right here. Now, as you can see with the mesh, it is a completely different color, and that's because this is not a body that we're more used to working with. This is just a way that we can represent a 3D model. So an important feature about STLs that are different from the other bodies that we're used to working with is that this is completely hollow. So if I just do a really quick section analysis of this, you'll kind of be able to see the very middle of it. It is completely hollow, and the walls have no thickness to it. This isn't like a container, this is more like a fabric that's folded around your object, where this has basically no information on the inside, and it just consists of all these triangles that go together to form our part. Because we have a low poly style, there may be only 100 facets that actually go to making this. But if you're going to be making something like an M5 bolt, for example, there are tens of thousands of little polygons that go together to make this. Normally they're triangles, but they can basically be any different shape that you'd like. So currently this is in a mesh form, and we can actually go up to the mesh menu at the very top. But as you'll see through here, this is really just a place to repair meshes if they have any holes, scale things up, scale things down, add more facets or make it more simplified. But for us, we just want to convert it from a 3D mesh into a body. This is something called a B-rep transformation. If we go into Modify, right down at the bottom, there is Convert Mesh, and this will take a 3D mesh and actually turn it into something that we're kind of more used to seeing. So we can go ahead and select our body. We can leave this as a parametric and a faceted formulation. This is just how are you constructing or going from all those facets to what your body is made of. So you can just click OK, and now this looks a little bit more familiar. This is that kind of classic shiny gray steel material that we're more used to seeing. So if we go back to the solid section, you'll actually see that we're able to click on all these individual faces, and we can operate or put features onto it just like more normally accepting. For example, if you wanted to extrude this one triangle at the top of its face, I don't know why you'd want to do that, but this is just kind of showing you that you can treat this just like any normal body that you can work with. If you had a file that you downloaded from Thingiverse and you wanted to turn it into a cup, you wouldn't be able to do it just by going through the mesh. You would have to turn it into the body just like we have now, and then put a hole through it. Now, because we're going to be working with a lot of parts that actually go in front of it and kind of make a box around it, we want to make this a little bit easier to see. So let's just go ahead and add an appearance right now. So you can type A on our keyboard and just type in red, anything you'd like. This aluminum red, yeah, that'll work just great. So click and drag it, and then we've got a really nice dark color that will be very, very obvious to us what's going on. Now, the whole purpose of this parametric project is to basically say, all right, what is the size of this? And then what is the box that we can make that changes according to the size of this? So if we wanted to, and we wanted to make another mold later down the line, we can take out this skull, put a new part in there, and then everything should shift around it. So the numbers that we're looking for to put into our parametric modeling is what is the bounding box? So we can figure out the exact volume of this, but if you were to draw a perfect box that just barely touches all the way around it, how large would it be? And this is what's called a bounding box. It is a terminology that's used all the time in CNC, CNC routers, CNC mills, CNC lathes. Basically, this is what is the large or the smallest material that you can use to actually carve out this process or this project. So we can go into our browser up here and we can right click where it says skull, and right in the middle it'll say properties. And this is going to pull up a little menu saying all the information about this project. So if we expand physical right here, you'll see, oh, this is the mass, the volume, the density. This is a very common area if you're ever finding any CAD projects online. This is being used to verify if you did it correctly. But we're going to be looking for the bounding box right here. And you want to write down these numbers. This will be how we'll define exactly how large our box is. So go ahead and write down whatever numbers these are for your project. Again, you can choose this low poly skull, but if you want to choose something completely different, absolutely go ahead. So now that we have those values, we're actually going to be going into modify and then change parameters. And this is where we can add in all of our parametric design. So we can go into our user parameters and basically define what is the X, Y, and Z dimensions of our part. So I'm just going to type in X_axis. Remember, you can't put any spaces in the name, so if you want to separate it, just call it an underscore. We're going to keep this in units, and our expression for this is going to be 1.635. That was that first dimension that we saw. And then we just can click OK. Now go ahead and do this for the Y and Z. So as well as the X, Y, and Z parameters that we have in there, we also want to be putting in our material thickness. So you can just type in thickness right here, and for our expression, we're going to be using 3/16 inch material. You can put in any fraction you'd like in that, and that's just going to spit out the decimal of it. And we also want to be putting in the clearance. Now clearance is the distance between the model and the walls. Now normally for a silicon mold, we want it to be about 1/4 of an inch. If you have that dimension too large, then you're really just wasting material. And if you have that distance too small, then those really thin walls are going to kind of sag and move when you put in heavy material in it. So this is looking great. All of our names are nice and accurate, and then we can just close that out by clicking OK. Now the first component that we're going to be making is the base that goes on the very bottom. And to do that, we need to first go up to this top section, and we're just going to save it as skull silicone. Well, just skull, that's fine for us. Go ahead and save that. And we also want to go up to this top file and activate this component. This means that when we add a new component, it's actually going to be in the same list as our skull. If we were to have this skull still activated, then it would make our skull now a sub-assembly on its own. So anytime we add a new component, we're always going to go and activate the very top file. So go ahead and add a new component. This one is going to be called the base, and then click OK. And as you can see, because we made a new internal component, our skull has now turned this kind of transparent color. It's not that it's changed or it's turned into a new material, because if we activate this, it still pops back to being normal. But because we're working on a new component, it's basically saying, yeah, your other components are there, but now it's just a little bit easier to kind of work around it. So for us, we are going to be making a new base that starts from the very center and extends all the way on either side. So we're going to be starting off by making a new sketch. We are going to be making this on the top plane. We're doing this with the bottom view up here. If you're ever at a kind of a funky angle and you can't get it exactly dead on, you can always just click where it says bottom, and this will put you into a perfectly orthogonal view. So we're going to go into create, rectangle, and center rectangle, and then we can click our origin, pull up and away, and then click again, and hit escape to get rid of that center rectangle tool. Now for the dimensions that we put on here, we basically want to say this wall is equal to our x-axis, which defines the width of our skull, and then also the thickness of our material on either side, and then the clearance on either side. So you can go ahead and click D for dimension, click our x-axis line, pull up, click again, and this is where we can put in a little bit of our formula. So I'm just going to type in X, and it's saying, yep, I bet you already want to use the X-axis. And then we also want to click plus 2 times the thickness as well as the clearance. And then we can close off that parentheses, and then you can see everything turns black to say, yeah, everything's good to go. And then as soon as I hit enter, it will take all of those functions and add them up. And you can see this dimension is in fact outside of the bounds of our skull, which means everything went well. We're going to do a similar thing for this vertical line, where we can click it, pull our dimension away, click again. This time we want to define the y-axis. Then we want to add on 2 times, and then parentheses, the thickness of our material plus the clearance. And then close off that parenthesis, and then hit enter. And there we go. That function now equals 3.317 by 2.51. Perfect. Now we can go ahead and finish this sketch, get a little bit normal view, and then we would like to extrude this the negative thickness, because we still want our board to have the correct thickness, but we want it to be going down so it doesn't accidentally go upwards and then interfere with our project. So we can just click OK. And because this is going to be made out of some foam core, we may as well add an appearance so it's a little bit easier to see what's going on. So we can type A for appearance, and styrofoam is basically just known as styrene. So if you look up styrene, polystyrene will pop up. We can now click and drag that onto our material and hit close. And because it's basically a styrofoam, if you zoom into it, you can see this kind of bubbly texture to it. So that's great. So now this component is completely done. So let's go up to the top and then reactivate that top file. And you can see both of our components are now in the correct location. So now let's go ahead and make the new components that will make up our side walls. So just like before, we're going to be adding a new component. These ones are going to be called side walls. Again, it is still an internal, but now we're going to be making a sketch on the very top of our base. And this one is even easier. We're just going to be making our 2 rectangles, and because we already said, hey, make this base and also include the thickness of our walls, we can just type R for rectangle, and then it will snap to this top corner, pull down till it snaps to that bottom edge, and do the same thing on the other side. Go up till it snaps to a corner, pull down, and then click again. Because we know we want these 2 walls to be equal, we can just add an equal constraint to it. So that top bar, that top bar. So now if we move this, the other one will change as well. And then the height is already done. We just need to set the thickness. And again, we'll be typing D for dimension, clicking that top line, pulling away, and this is very simply just our thickness. And because we've made this in a parametric model, if we decide later down the line, oh gosh, I can't find any 3/16 inch material, I can only find 1/4 inch, you can just go up into that change parameters section and say, yep, under thickness, I'm going to change that to 1/4 inch, and then everything will then increase in size according to whatever dimension you put in place. So you can say finish sketch, and now we just want to extrude this vertically. So go ahead and click on the 2 rectangles we did. Now, as far as the height, if we just type in the z-axis, it's going to mean that the very top of this lines up with the very top point of our skull. Unfortunately, because we're pouring in some material, it wants to go right up to the line and then a little bit extra on top. So we're going to type in z, say enter, and then we want to add in some clearance as well. And this means when we pour up all of our silicone, we can add it all the way up to the top. So then our clearance will be perfectly even all the way around. Now we can click OK. And just like the other piece, we can also add in our polystyrene appearance to this. Great, and now we are done with these 2 side walls. We can go ahead and activate our very top file. Now we're going to make our front and back walls, so go ahead and make a new component. Name it appropriately, still keep that internal piece, hit OK, and now we're going to be making a new sketch again on the top of that base. We'll be still using our rectangle tool, and we want to kind of snap to that top point, but as you can see, that corner there doesn't quite want to grab. It wants to grab to this line, but not necessarily to the top corner, and that's because this rectangle is actually on the very top view. So to correct that, we can hit escape to get rid of that rectangle tool and click P for project. Now we can click our 2 rectangles, and that will project those top surfaces actually onto the surface that we're working on. So now we can go back and use our 2-point rectangle tool, click away, it should snap to each wall, just like normal. Just like with our other walls, we're going to be using our equal tool to make the thicknesses of each side perfectly even. So now again, if I change one, the other one will change as well. And we also want to add the dimension of our thickness. There we go. Very often, anytime I'm doing CAD, the biggest bit of advice I can give for people that are starting CAD really brand new is use as few number of dimensions as possible. The more dimensions that you add on means the more things you may lose track of, and so having things in a way where they're either parametrically driven or constraint driven, where instead of changing like 50 dimensions, I only have to change a handful, it makes life much easier, and it actually makes things a lot more accurate as well. So this is looking fine, so let's go ahead and finish sketch, and then we can also extrude up this front and back profile. And we can pull this up, again, our Z-axis plus some clearance. If we wanted to, we could also say the extent type would be to the object, and then we could also click on the very top of this wall. So either way works for us. And then let's go ahead and add on that polystyrene. But because we've used it a couple times, it's now going to pop up as in this design. So we can just click and drag that. We don't even need to type it in. So click close, click close. And then let's activate this top part, and there we go, our box is now done. And because we're going to be putting some sketches on the bottom face of there, and it's a little hard to see the skull right now, we may as well make this front wall a little bit more transparent. So let's go ahead and go to our front wall, and we can expand this so you can see the two bodies that make this up. That would be the front wall and the back wall. And we want to change the opacity of this. You can right click the front wall, go all the way down to opacity control, and let's make this 50%. So now it's a little bit easier to see the skull inside. And now we can go and compact that part in the browser. So currently, because we are making components, all these components are in the right location, but unfortunately, if you click one, you can actually drag it and move it out of the way. This is bad news. Any components that you want to stay in the correct location, you want to make them rigid. If we wanted to, we could go into all of our assemblies and add individual joints to all of our pieces. I'm going to put them in the right location just by undoing with Control Z, by the way. But another really fast thing to do is add what's known as a rigid group. A rigid group basically says, hey, everything, stay in the right location. It's very similar to using the fix or unfix constraint tool in the sketch, where we don't really care about any dimensions. We're just saying, hey, stay in the same location. So for our components, we can click all these pieces, or you can go into the browser. So I'm just going to click these top components, hold down Shift, click the bottom components. That'll now highlight everything in there, and then click OK. And now if I try and move one, the other ones will hold with it as well. I don't really need to move it from the origin, so we can just do Control Z and hold that in place. I can keep it firmly locked in place as well by grounding one of these pieces. So I can just go and select my skull, right click it, and then say ground. And yep, I would like to capture that position. Now the skull is completely unmoved, and because we've said that everything that's connected to the skull is also grounded, now if I try and click and drag any of these, it's completely locked in place, which is what we're looking for. Our final component is going to be our silicone. So go ahead and make a new component, and whoops, you're going to be wanting silicone, not silicone. We want to keep this as an internal component, so click OK. And we are basically wanting to make a cube that starts from the very bottom and encompasses our entire project. So go ahead and create a sketch on the very bottom plane. And then we want to use these corners in there. So we can hit P for project and then click on all these walls. And this will allow us to use these corners as information for our pieces. So we can make a 2-point rectangle and just click from that point all the way over to the bottom point. And then we can go ahead and finish our sketch. And then we can extrude that new profile all the way up. We can set it to the extent, or again, we can just type in Z-axis plus the clearance. And currently we now have our skull that's kind of hidden inside. And we need to basically say, hey, keep the skull where it is, but take away all of this new silicone that I've put in there away from our piece. But first, before we do that, we actually want to add a physical material to this. So a big question that I get asked is, what is the difference between an appearance and a physical material? So an appearance is basically just keeping the steel that is the default material to it, but change the outside kind of color. So if we made it glass or if we made it wood, we're basically just adding a decal, adding a sticker to what is essentially still steel on the inside. If we add a physical material, we're actually changing the outer decal, the outer appearance, and the material on the inside as well. So if we go into modify, we can go all the way down to physical material, and this is where we have a new pop-up where we can add in material to it. Because I'm looking for the actual weight of the silicone, I can't just use steel. Silicone is far less dense than steel, so I need to know exactly what material that is. So let's go into our physical material. There is no search menu, unfortunately, but we're going to be expanding plastic, and we're going to go all the way down to rubber, silicone. Rubber silicone is, or silicone rubber is the correct name, is really the most common molding material that you'll come across. It is a very thick, goopy material, but when it cures, it captures every single small little bit of detail that you can possibly get. So you can click and drag this onto there, and it is normally this kind of pasty clear white, and so you can kind of see it has turned into this big white cube. So for this project to work, we basically need to cut away the skull from our silicone, but still keep the skull in place. Right now, the skull and the silicone block, they kind of harbor the exact same location. Even though we've said, hey, there's a skull here, there is also silicone in place. So if I do a section analysis at the very top of it and I pull it all the way down, you can see, well, it's kind of freaking out. It's saying, yeah, well, this is silicone and it's also the skull, and it's like, I don't really know what's going on here. So let's cancel it and let's use a new tool and actually combine what it is, the silicone and the skull, but also cut it away. It's a very confusing name for this piece, but we're going to be going into modify and then using combine. So not only can we merge two bodies together and kind of hold them as one, as the name would imply, combining, but we can also do a combine cut. It's a little bit easier to kind of understand as you're using it, but we basically need to say, all right, what is our target body and what is our tool body? So for this circumstance, we want to keep our silicone and we want to cut away the shape of the inside with our skull. So our target body will be the silicone, and if we turn off the silicone in our browser, then we can get access to click our skull, and then we can turn back on our silicone. In the operation section, instead of keeping it as joined, we want to keep it as cut. There we go. So now we have our silicone is actually being subtracted with the shape of the skull, but we still want that skull to be there, so we can check keep tool. And then when we click OK, well, everything should kind of look a little bit normal. It's kind of glitching out right there, don't worry about that. But when we do a section analysis of the very top of it and we pull down, you can see we have our skull as a completely separate entity of this. If we take that skull away on the top section and we do that same section analysis, we can now see the internal volume or the internal profile, the shape of what that skull would be, and then we can turn that back on and the skull pops back into place. And now very finally, we are going to be right clicking on the silicone, going to properties right in the middle, and then it's going to be loading up. We want our physical material, and we are going to be using 7.267 ounce mass of silicone for our project. Fantastic. So anytime you guys are working on a silicone molding project, absolutely go ahead and mess around with this file so you can put in any STL you'd like and then figure out exactly how much silicone you need.